Hello students, in this lecture we are going to discuss differentiability, some rules of differentiation and one theorem related to differentiability and continuity. So let us start with differentiability. In class 11th also we had studied about differentiation. So here we will discuss differentiability and then some rules of differentiation which we had already studied in class 11. So differentiability. Suppose f is a real function. Suppose f is a real function and C is a point in its domain. The derivative of f at C is defined as f dash C equals to limit h tends to 0 f C plus h minus f C by h. For any x we can write this as f dash x equals to limit h tends to 0 f x plus h minus fx by h. Now we will discuss some rules of differentiation. First rule, u plus minus v dash. This is u dash plus minus v dash. Second rule, uv dash. This can be written as u dash v plus u v dash. This is called Leibniz or product rule. Leibniz or product rule. Okay? Here we have the product of two functions. That's why this is called product rule. Third, u by v dash. This can be written as u dash v minus u v dash by v square, where v is not equal to 0. This is called quotient rule. Okay, now we will discuss one theorem. The theorem is if a function f is differentiable at a point C, then it is also continuous. Then it is also continuous at that point. Okay? So if a function f is differentiable at a point C, then it is also continuous at that point. So this is the theorem. Now we will prove this theorem. So the proof is like this. Since f is differentiable at C, since f is differentiable at C, therefore, by the definition of differentiability, limit h tends to 0, f c plus h minus f c by h equals to f dash c, by this definition. Now, if we put x in place of c plus h, means x in place of c plus h. Now, as h tends to 0, so here if h tends to 0, it means it is 0. Then what happens? X tends to c. Then x tends to c. And from here, the value of h is what? X minus c. So this can be written as limit x tends to c. In place of this c plus h, we can write x, fx minus fc, and in place of h, we can write x minus c. So this is x minus c, it is f dash c. Okay? Now, for any x not equal to c, for any x not equal to c, we can write fx minus fc as fx minus fc. Now multiply and divide this by x minus c. Okay? Now this can be written as limit x tends to c, fx minus fc. On this side also, limit x tends to c, this is fx minus fc, x minus c, and this is x minus c. Okay? Now, on left side, we can separate this limit. So, this can be written as limit x tends to c, fx minus limit x tends to c, fc. On right side, also we can write limit x tends to c, this is fx minus fc by x minus c multiplied by limit x tends to c, x minus c. So on both the sides, we separate the limits. Now, this left hand side there is no change. Limit x tends to c, this is fx. Limit x tends to c, this is fc. Now on right hand side, this is nothing but f dash c. So this is f dash c, and when we put x equal to c, this becomes 0. So altogether we can say that the right hand side is 0. On left hand side, we can write limit x tends to c, this is fx, and this can be written as limit x tends to c, fc. Now, Further, we can write this as limit x tends to c fx. When we transfer this on the right hand side, then this is simply fc, because there is no use of this x tends to c, because here we have only c. There is no place to put the value of x. So by the definition of continuity, from this it is clear that the function f is continuous. So we can write, hence the function f is continuous. So in this way we can say that whenever a function is differentiable, then it is continuous also.